Hello, in these videos we're going to be going through the example circuits that were included with the Arduino starter kit I've got from the Bill Ross here. There are 12 different example circuits included with this, and the kit includes all the various components you need to assemble those circuits. And once we've completed those, we'll move into some different elements which use similar principles but aren't included with the starter kit. The general format of these videos is going to be I'll show you a schematic of what the circuit side of the project will look like, followed by going over the coding included in the Arduino sketch. Then I'll show you the actual physical circuit on my prototyping breadboard that I've got. And finally, I'll run the program and show you the verification that yes, the program is in fact doing what it's supposed to be doing. Alright, so this first example circuit is fairly simple. It's just going to have an LED blink on and blink off, and it'll just run that blinking light forever. So for this, we're going to take our two components, which are an LED and a resistor. We have an LED with its positive end and the negative end, and then a 330 ohm resistor that was included with the kit. We're going to pull off a digital output from pin 13 on the Arduino, connect it to the positive end of our LED, the LED to the resistor, and then connect the resistor back on down to ground on the Arduino board. And we've connected the LED and the resistor. The resistor is to limit the current flowing through the LED so that we don't burn out either our board or the LED in this case. Now there's an alternative way you can show this sort of thing. This shows the sort of complete circuit loop, how you would think of it and sort of hook it together and wire it up on the breadboard. But you can also show the circuit this way, where you connect from pin 13 out to the LED, LED to resistor, and resistor to just ground. A ground mark here, and you connect ground on the board also to a ground point here, and it's assumed that all ground points are equal and connected together. So this point connected to ground is invisibly wired as such, so that those 2 points are connected even though it wouldn't be shown on a schematic. So the actual schematic would not have these lines. It would just have the two ground segments, but you can think of them as being connected. So this is a fairly simple circuit, just an LED and a resistor, and it's got a fairly simple program to go with it. So when you open up your Arduino sketch for these example circuits, they've got a whole bunch of comments. These example circuits are very, very well commented. They include a lot of description about what they're doing and why they're doing it and what each of these commands do. So you should be able to figure out how the sketch actually works from the comments included. I'll be providing some additional commentary and explaining some of the things that would be explained in those comments. So your Arduino sketch comes in two halves. You've got setup and loop. So setup and loop. And your setup is everything that you want to do at the beginning of the program. It's going to run all these things once as part of the initialization before moving over to loop. And the loop is what you want your program to actually do, and it's just going to repeat whatever's included in this loop text endlessly. So for this one, where we're going to be outputting from the Arduino to a circuit element, in this case the LED, the first thing we need to do in setup is this command, pin mode. Pin mode takes two parameters: the pin number you want to assign a mode to, and the mode you're setting it to. In this case, you're taking pin 13 and setting it as an output pin. So if we go back to our schematic for a second, you can see that there's a bunch of digital pins running down the top side of the schematic. We're talking about digital pin 13, and we're setting it to output. Now when we call the loop, the first thing the loop does is called a digital write command. This says, go to one of those digital pins, and the first parameter is the pin you want it to go to. In this case, that's 13. And the second parameter will either be high or low. And with a digital output, high and low for our Arduino board will be 5 volts or 0 volts. So high is 5 volts, or provide power. So when it writes high to the pin, it should turn on the LED, since the other side of the LED is connected to ground. The next command is delay. Since your computer can process commands very, very quickly, this delay says, wait, hold up, don't run any additional commands until this delay period is passed. And the delay period says, wait the number of milliseconds given by the parameter included in the delay command. So when you tell it to delay 1000 milliseconds, it's going to wait 1 second before proceeding to the next command, which in this case is digital write 13 low. This says, go back to pin 13 and set it from being 5 volts back down to 0 volts. And then delay for another second, and then you hit the end of your loop code, which will bring it back up to the top, and it's going to start again with go to pin 13, turn it up to 5 volts. So very, very simple program. Just goes to pin 13, sets it to high, waits, sets it to low, waits, sets it back to high again and again. So if everything's hooked up correctly, this should produce just a blinking LED. So here's my prototyping board and Arduino board. Now these running down the far side that you can barely see on the camera, these are my digital pins. These running down the near side are analog pins. Yeah, these ones right here. These are the analog pins. The analog pins also include a fixed 5-volt output for times when you need that, but it also includes the analog read-write pins down here. And this is a breadboard where you can stick in your various circuit components and test your circuit to make sure it does what you want it to do. And it's basically a field of little holes, which are just barely visible on the camera right now. And it's got 2 columns down each side, here and here. These 2 columns barely visible, but these ones right here. You'll notice one's marked, one's sort of got a red line going down the column, the other one's got a blue line down the column. It's not exactly visible, but the red is marked with a plus, the blue is marked with a minus. What these are meant to do is that you're supposed, when you pull off, say, the plus 5 volts from the analog side of the Arduino here, you'd connect it into this red column here, because all of the holes in this red column are connected together. So once you connect 5 volts to, say, this top hole here, you can pull off of any of these other holes here to get that 5-volt source from the Arduino. The blue negative is meant to be the same thing but with ground. You connect this top thing over to ground on the Arduino board, and then you connect everything that needs to be grounded over into this blue area here. Now, these are connected by column. The main body of the breadboard has a grid of holes, but these holes are connected by row. So everything in the same row is connected together as long as it's on the same side of this big divide in the middle. So in row 1, you've got 5 different holes here and 5 different holes here. These first 5 are connected to each other, and these second 5 are connected to each other, but none of these first 5 are connected to the second 5. So you can have something that goes from one side of the big gap to the other, and you haven't accidentally shorted across that component. Now, I haven't actually assembled our simple circuit this time, because this one's going to be fairly fast, and I can just build it for you right here. So we've got our LED, and it's got 2 leads coming off of it, a long one and a short one. The long one is the anode, the positive end of the LED. So when I stick it into the breadboard, I've got it straddling 2 different rows here. So I can connect something to the front row and something to the back row. And I'm going to connect to the back row my current limiting resistor. So I'm going to connect the resistor from the back row over to the blue line on this side for ground. And I'm going to get some wires. And I'm going to connect pin number 13 to the same row that I've got my positive LED in. And then I'm going to connect the ground column back over to ground on my Arduino board. And so I've just got this wire, which is from Arduino pin 13, over to the positive side of the LED, which is then connected to the resistor, which is then connected back to ground on the Arduino board. So if I have everything hooked up correctly, then once I go back to my sketch and upload it to my Arduino board, that LED should start blinking on and off 1 second each. So back to the sketch. Let's upload the sketch. And then we go back to the board, and yes, the LED is blinking on and off. So simple sketch, simple hookup, and that's how you can use your digital write on your Arduino board to send a simple control signal out to an element like an LED.